Alright, so we're going over the homework from the worksheet 5.3a. Alright, and we'll start at number 17. So it's log base negative 3. Oops, what am I doing there? Why did I put an E? Negative 3 of... Now, they don't put a parentheses here. I probably would. You don't need to, but it just kind of looks weird with that negative, that minus just sticking out in the middle of nowhere like that. And that equals x. Alright, this is what we're trying to find. So, actually, you could do this on a calculator. You remember the change of base theorem?
It's similar to number 1.
Yeah, it's kind of like 1 through 8, really, to tell you the truth.
Look at number 1.
Look at number 1, yeah. Except with the negatives, right? That's the only thing different about that one.
Just put C number 1.
Why don't you just do the problem? Watch.
Because I'm too lazy.
Okay. Watch. Let's do the change of base theorem. Actually, before you do the calculator, we'll do this. There's a couple ways you could do this. You could do this without the change of base theorem. You could have done this. You could have, let's do it this way, and then we'll do it this way. All right. So here's one way to do it. You could change this to exponential form. So let's do that. So we go negative 3 to the x power is equal to negative 243. You should be getting used to that by now, changing it from logarithmic to exponential. Right, you had a whole bunch of them on this worksheet. That's what you had to do. All right, but this time we're actually going to get x by itself. Remember the lesson we had before this where we had to get the bases the same? So let's see if we could get the base to be the same. For instance, this right here. And by the way, to tell you the truth, we could just get rid of the negatives right now. Like if I divided both sides by a negative, what would that make that? It would make it positive, wouldn't it? So I don't even have to worry about my negatives now. Does that make any sense? I just divided everything by a negative 1. Alright, so that turned to positive and that turned to positive. Let's do this. Is there any way to write 243 with a base of 3? Is there any way to write it? Well, I don't know. 243 doesn't really ring a bell with me, but let's try some numbers. Alright, let's try 3 to the, I don't know, what would be a good one? I know 3 to the 4th. 3 to the 4th is 81, right? So let's try 3 to the 5th, see what that is. How about that? Lucky guess, right? It was just the next one on my little list, right? Because I got 3 cubes, 27. 3 to the 4th, I know is 81. We've dealt with that one quite a few times. So I just try the next one up. 3 to the 5th is 243. How about that? So that's 3 to the 5th. Now, the bases are the same. X is equal to 5. So that's one way to do it, and that's perfectly fine. There's another way to do it, and we learned this yesterday. Technically, remember yesterday I kind of went ahead of myself a little bit, did this change of base theorem, and it really wasn't taught until the next section. But I showed it to you anyway. So let's write it down as a reminder. The change of base theorem. Just shorten that. All right. And what did the change of base theorem say? I forget what letters we used. What did we use? I'll use that. All right. What if we had something like that? Okay, log base b of x, and I'm trying to figure out what that's equal to. And these are numbers, all right? They're actual numbers that they're going to stick in here for b and for x. But what do? We just take the log of x divided by the log of b. Now, there's no base here with this log, so what does that indicate to you? That what is the base? It's 10, right? And you can actually do that on your calculator because they've programmed this log button, log right here, they've programmed that to be a log base 10. So I can do this. I could actually use the log or the natural log, the ln. It doesn't matter which one. We'll just use the regular log. Actually, do it both ways. So actually, before we do the calculator thing, let's stick the stuff in here. Does this fit? Right there. Yeah, so what do? We could do the log of x, the log of the number. So what are we going to do? We're going to go the log of what? Negative 243, right? Over the log of the b, which is the little base. What's the little base here? It's negative 3. All right, and you can just plug this into a calculator. Now, it was kind of nice here that you didn't really need a calculator. I mean, the 3 to the 5th, okay, we used it for that. But on this one, you just punch them straight into a calculator. Let's see what we get. So it's the log of negative 243. So log of negative 243 divided by the log of negative 3. So you hit the log of negative 3. All right, hit equals, and I get an error, of course. Why do I get an error? What did I do? I don't know why I got an error there. It probably is. Let's see. Oh yeah, of course. Remember, on that one problem, remember the answer was undefined? And I said we'll talk about it a little bit later. I should have thought about that here. There is a rule that says you cannot take the log of a negative number. I never mentioned that yesterday. And I'll show you why that's true in a little bit when we get to that other problem. But you're absolutely right. You cannot take the log of a negative number. So what we're going to do is we're just going to take the log of a positive number, 243, divided by the log of 3. Let's see if that works for us. Yep. And look at that. We get 5, just like we got before. All right. Now this was kind of nice. They rigged this one for us. How did they rig this for us? Because I could write 243 with a base of 3, right? I could get the same base here. That's not always going to happen. All right. There are times where you're not going to be able to get that. Now on this lesson, they'll probably rig a lot of stuff on this lesson. Because they haven't technically shown you that change of base theorem. I just thought I'd throw that out there early, and it might be a little bit helpful. So when we get to it, then you'll have a little bit better understanding. All right? So anyway, that's how to do it. This is the way that they probably want you to do it. All right? But you still get the same answer either way, which is kind of nice. Tell you what, from now on, let's wait until the next lesson to apply the change of base theorem. All right? I probably shouldn't have skipped ahead so quickly, but let's keep going. Let's change colors here. All right, number 18. Let's try number 18. These are all pretty straightforward because they just, I'll tell you, we'll just do one more of these. Let's say from 18, 19, or 20. Which one of those would you rather me do? 18, 19, or 20? 19? Okay, I heard 19, so we'll do 19. So this is log base 9 of the square root of 9 to the 12th. Wow, that's weird. Equals x. Let's see how I want to approach this. I'm thinking about simplifying this thing before I do anything else. Before I change it into exponential form. Let's just change it to exponential form, then we'll simplify it. It wouldn't make much difference. So let's do this. It's in logarithmic form, so I want to change it to exponential form. So this part, you really should know. I'm expecting you to know how to change it from logarithmic form to exponential form. You've had enough practice on this. Even though we've only really talked about this one day, you still should be able to do this. You take the base to the number, the base to the exponent equals the number. Okay, remember, when this is equal to the log of something, this is the exponent. X is actually an exponent. So what is it? It's 9 to the what? To the x equals this crazy thing. 9 to the 12th. Let's do this. Let's go off to the side a little bit, and let's just simplify this. This is kind of ugly. We've got a square root right here. Taking the square root of an exponent. So you could look at it a couple different ways. Watch. I'm going to take 9 to the 12th. Instead of writing it as a square root, let's write the square root as an exponent. What is the square root as an exponent? To what power? Talked about this.
6.
Well, now you're getting ahead of me. You're not answering the question I asked. It's 1/2, right? The square root is a 1/2 power, right? We've done that plenty of times. Remember this? Square root of x equals x to the 1/2. We've done that before. All right? It's just a matter of you remembering what we've done before. All right, so what is this? This is to the 1/2. Now, Tiffany said it, but I wanted you to see where we got it, not just what the answer was. So this is the same thing right here as this. It's just the square root of 9 to the 12th. Now, we have a rule with exponents. When we take an exponent to another power, we multiply the exponents together. So 12 times 1/2, or half of 12, is 6. So I'm going to write this as 9 to the 6th. So watch what we get. We get 9 to the x equals 9 to the 6th. Look at this. We got the bases the same already now, don't we? The bases are the same. What do we do with the exponents? Just set them equal to each other, and there you go. That's how they want you to do this. All right, write it down. Go back to the video if you think I went a little quick. I think I explained everything I needed to here, but we need to move on. All right, let's do... So 18, 19, and 20 are pretty much the same style of problem. 20 is pretty much just like what we did on 19. So let's go to 21. This is a little different because now you're solving for the base. X is now the base of 243. That number looks familiar. What am I doing? Why did I put an equal sign here? Let's try that again. 243 equals 5. Alright, it's in logarithmic form. We want to change to exponential form. We've done this a bunch of times now. So first thing I do is I take the base to the exponent. Remember, this is the exponent. Whatever is equal to the log of whatever, that's the exponent. So it's going to be x to the 5 is equal to 243. Now this should look a little familiar to you, shouldn't it? Because we just finished doing one. Remember what 243 is? What is that? It's 3 to the what? 3 to the 5th. Now look at this. What to the 5th power is equal to 3 to the 5th power? What should x be in order for these to be equal to each other? It's got to be 3, right? Yeah, because this is 3 to the 5th. If they're equal to each other, this has got to be 3 to the 5th. Would you agree? So this time the bases aren't the same, but what's the same? The exponents are the same. So guess what must be true about the bases then? They got to be the same. So x equals 3. Does that make sense? It makes sense because if I know that they're equal to each other, okay, what to the 5th equals 3 to the 5th? Well, 3 to the 5th equals 3 to the 5th, correct? And that's how you get that answer right there. Does it make a little more sense? Again, there's a little bit of some kind of tricks in there, right? They're not real tricks, but they're things that you just have to know what's going on. Look at 22.
That's the one I lost.
Okay. So let's do this in another color. I think we can slide it in right here. 22. X equals, now this is a little different, 4 to the log base 4 of 17. Wow, that's crazy. Well, let's try to figure out what's what here. What's going on? Let's get this color. This is our base, correct? And this whole thing right here is our exponent. So let's do this. This is an exponential form, isn't it? Even though you see a log right there, this is still an exponential form because it's a base to an exponent. All right. What I want to do is I want to change it to logarithmic form. So how do we change exponential form to logarithmic form? Well, I go the base. I'm sorry. I was thinking the other way around. What am I doing? I go log base what? What's my base here? 4 of what? I've already got my 4 there, so I've already used the 4. Log base 4 of what? Of x equals what? My exponent. Remember, my exponent is the one that's sitting there equal to the log. All right, so equal to the exponent. What's the exponent here? It's a log base 4 of 17, isn't it? See what I did? I just changed it from exponential form to logarithmic form. I went log base 4 of x equals the exponent, which is this crazy thing right here. Now this is a little weird because you're not used to seeing a logarithm in your exponent. It's probably the first time you've seen that. But it still works the same way. So go back and look at that rule. I'm not going to write it down, but look at the rule for changing exponential form into logarithmic form, and it flows perfectly like that. Now, once we have it set up like this, again, this is rigged a little bit for us. Look at this. This says the log base 4 of something equals the log base 4 of 17. So what do you think x is? It's got to be 17, right? In order for them to be equal to each other, if this was equal to this, if they're the same thing, what must x be equal to in order for them to be exactly the same? It's got to be 17, right? You follow me? So x equals 17. Now watch this. Let's look at this differently. Instead of having to go through this every time, we kind of came up with a little, I don't know if you would call it formula, but watch. We could do this a lot easier now. Log base 4 of 17. Remember we said what x was equal to? We said x was 17. So what does it look like this base 4 and this log base 4 do to each other? If my answer is just 17, what happens to this base 4 and this log 4? What do? They cancel each other out. Exactly right. I showed you why they cancel each other out right here. Okay, I showed you that we're just left with a plain old 17 for our answer. So all that stuff just went away, didn't it? So this base 4 canceled out with this log base 4. So when you have a situation like this, when you have a base to a logarithm, and if they're the same bases right there, they're going to cancel each other out. Now, if this was like log base 5, they wouldn't cancel each other out. But as long as these are the same bases, this is log base 4, and this is just a regular base 4, they will cancel each other out, and you're just left with x equals 17. So again, it's another little trick. It's another, what's the word I used yesterday? It's a little technique. Thank you, Norval. It's a little technique that we use to save us a lot of time and a lot of effort. All right, and you just have to recognize it. When you see that problem, you're like, oh yeah, it's one of those problems where the base 4 and the log base 4, this cancel each other out. So that's kind of a nice problem, isn't it? Once you see that. Yes? Not much reaction, but I don't know. I thought that was kind of nice because the easier the problems, the happier I am. Aren't you? When they're super easy. And I think that's a super easy one. So when you see something like that again, well, I'll tell you what, I'll just do another one. I'll just make something up. All right, if you said x equals 5 to the log base 5 of 7, what's that equal to without doing any math at all? 7. That's all it is. Okay, x equals 7 because that cancels that, and I'm just left with 7. All right? Okay. Let's do 23. Each of these have their own little twist to it, all right? And you have to kind of think about it. It's almost like a little puzzle, you know? It's not, you're not doing the same thing over and over and over again, even though there are some things that are in common. There's little tiny things that you have to think about, and you have to use your ingenuity a little bit. So this is log. That's supposed to be a base 10. It kind of doesn't look like it. It looks a little big, doesn't it? But that should be base 10 of this number, which is, how many zeros? Count those zeros up. I can't see in the dark. 6, 1, 2, 3, 4, 5, 6, and then a 1. All right? And this is what we're trying to find. All right? See number 12? Was number 12 like this? Yep, number 12 was kind of like that. What we're going to do is this. You could actually use the change of base theorem if you wanted to on this, put it in the calculator. All right, and that would be okay. But let me show you a little bit of a different way to do this. Let's take this and let's rewrite this. All right, let's rewrite this if you know how to work with exponents. Let's write it so it has a base of 10. Do you think I can write this with a base of 10? You may not like this because you may not remember how to figure this out. How many places do I have to move my decimal to get a 1 here? 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5, 6, 7. I got to move this 7 places in order to move it all the way to the right of 1. So what's that going to make this? 10 to the what? Negative 7th. Do you remember doing that?
Yep.
That was something you probably did in just regular math classes, right? Not even algebra. Okay. Well, I don't know. Maybe you did that in algebra. It could be science class, right? You probably did a lot of that stuff in science, didn't you? Didn't you do, negative exponents, 10 to, all that kind of stuff? Yeah.
EE stuff.
Yeah, yeah. So, you could write it like that. So let's rewrite it. So watch. X equals log base 10 of what? 10 to the negative 7th. Now look at this. You could, again, put this into exponential form if you wanted to. Let's just do that, but then I'll show you the little trick. All right, you should recognize something. Do you see this log base 10 and then another base 10? What do you think might possibly happen? This is not exactly like the other problem we did, but it's really, really close. Let's just change this to exponential form. So how would I change this to exponential form? Take the base to the exponent. Remember, this is the exponent, equals the number, and that's 10 to the negative 7. Look at this. I got the same basis, so what's x equal to? It's equal to negative 7. Instead of going through that step, you could have just looked at it and said, what? What happens to that log base 10 and this 10? They cancel out, so what's my answer? Negative 7. Isn't that nice? All right, so if you see a log base 10 and a 10, or a log base anything, and the other one is the same exact base, those will just cancel out. But what was the key to this? The key to this was knowing to write that decimal as 10 to the negative 7th. If you were able to do that, the rest wasn't that hard. But again, if you got stuck and you weren't really sure about it, you could always put it into your calculator and do the change of base theorem. Let's do it in the calculator. And let's see what we get. So what are we going to put in the calculator? We're going to put log of that big old number. Okay, so I'll hit log of 0.1, 2, 3, 4, 5, 6, and then a 1. All right, and then divide that by what? Log of what? 10. All right, let's see what we get. Boom, -7, just like that. So the change of base theorem comes in handy sometimes. If you didn't know, if you didn't know the little technique that we just did right there, you can always rely on that change of base theorem. All right, if that's all you want to do is get the answer, and that's pretty much what we want to do here, you can just put it into a calculator, know how to apply that change of base, and then you're good to go. Make sense? All right. We got 2 more to do. Might as well just finish it up, right? Hopefully you're writing these steps down. You're not just sitting there and just writing down the answers and just letting me do all the work. You should be writing all these things down. Because if you don't write this down, you're not going to remember how to do them. All right, there we go. All right, what do you think? I'll let you think about this for a second. It's in logarithmic form, isn't it? So what would maybe be a good choice? Change it into what? Exponential form, right? So how do we change that into exponential form? I always start with the base, right? And what's our base here? X. Take it to which power? To the -2nd. Good. Take it to the -2nd, and that will equal what? 1/25. Good. You say, well, that sure didn't help me. I don't know how to do that. Well, let's think of this. This is an inverse, isn't it? That thing's an inverse. What's another way to write this inverse? Instead of 1/25, we could write it what? 5. Well, let's write it like this. That's what you said. You said 25, right? 25 to the what? Negative what? First. And you say, well, okay, that still doesn't help me. Look, I don't have the same base. I don't have the same exponent, do I? But we could do one more thing to this 25. What do you think we can do to it? Make it 5 to the what? Yeah, make it 5. Right. Let's do separate steps here, okay? But it is going to be 5 to the -2nd. Watch, we go 5 to the 2nd. That's 25, isn't it? And then we can take that to the -1st. I'm showing every little step here. You might be able to do this part in your head. All right, let's look at this. So now, what is this? Exponent to another power, multiply them together. This is 5 to the -2nd. Now look at it. What do we have here? We got bases with the same exponents, right? So what to the -2nd is equal to 5 to the -2nd? Well, 5, right? Yeah, 5 to the -2nd equals 5 to the -2nd. See how easy it is to solve for x once you get it in that situation? And x is just equal to 5. Because if I stick a 5 right here, I get the same thing. They're equal to each other. And that's how you would do that. What do you think of that? We good? Thanks. Appreciate it, Morgan. Let's do number 25. X equals, it's pretty much the same thing, pretty much. A little bit of different look to it, but. And this is the, look at this, the 4th root of 27. Can I even do that? Can I even take the 4th root of 27? Is there something if I multiply it by itself 4 times is 27? Nah. I got 3 cubed is 27, right? But there's nothing to the 4th power, right? 2 to the 4th is not, it's 16. So there's no whole number to the 4th power that's 27. But I can make this look a little bit better than what it looks right now. Because, remember up here, we changed, where was it? Where'd you go? Ah, right there. Remember right here, we changed that square root to a 1/2 power. What are we going to change a 4th root to? To the 1/4 power, right? So let's do that right now. We'll just keep this log base 3. And let's change this right here. So I'll do it off to the side. So this is going to be 27 to the 1/4 power. Everybody with me? But I've got a base 3 here, don't I? It's log base 3. Again, they've rigged this, haven't they? All right, they didn't just pull 27 out of the blue here. I mean, they did this on purpose. So how can I rewrite 27 so it has a base of 3? 3 to the 3rd, and that's to the what? To the 1/4. We just talked about this rule a second ago. What's the rule here? That's going to be 3 to the what? 3/4. That's right. So 27 can be rewritten 3 cubed. That was already to the 1/4. The rule says that I can multiply these exponents together. 3 times a fourth is 3/4. So I can rewrite this 3 to the 3/4. You see how it's rigged? Because what happens now? What happens to this log base 3 and this big base 3? What do? Cancel each other out. Boom, boom. What's x? 3/4. That's how you do it. So again, there's little techniques you have to do. I wouldn't call them tricks, but there's little techniques. There's little things that you have to know to manipulate the numbers to get them to work the way that you want them to work. Okay? Because you know what you want to eventually accomplish. You eventually want to accomplish getting this to be the same base as this right here. And how do we do that? Well, let's get rid of the fourth root. I mean, fourth root is ugly, so we change that into a exponent. And then you look at it and you say 27, base 3. Oh yeah, 3 cubed is 27, right? Then you multiply those together. They cancel. 3/4, boom, you're done. Make sense? All right. Well, I had planned to actually teach the next lesson today, but obviously we ran out of time. Would it be that horrible if I gave you another worksheet on this kind of stuff? Give you a little practice?
I mean, yes, it would
Well,
be that horrible.
Well, it was actually a rhetorical question. I wasn't going to depend. My decision wasn't dependent on your answer, but just thought I'd throw it out there. Yeah, I could probably run one off real quick. We got a few minutes.
No, you don't.
Yeah, I do. All
No,
right.
you don't.